Okay, objective 7 talks about identifying the slant asymptote. We're in 3.5 still. Alright, so remember we talked about slant asymptotes earlier when we talked about the other type of asymptotes. We said that they only exist if the degree of the numerator is greater than the degree of the denominator by 1, and we find them by either doing long or synthetic division. So, first thing here, it says find the slant asymptote. So let's just verify that one does exist. So find the degree of the numerator and the degree of the denominator. Is the degree of the numerator greater than the denominator by 1? The degree of the numerator is the 2 because of the exponent. The degree of the denominator is 1. So the top is bigger than the bottom, and it is by 1. So a slant asymptote does exist. So we're going to use division to find that. Now, if what we're dividing by is x plus or minus and an integer, then we can use synthetic division. If it is not, if it was like x minus 1/2, or 2x plus 3, or if it had x squared in it or something like that, we have to use long division, okay? But this one is x plus or minus a number, so we can use synthetic division. So remember, when we take that number away from the x, we change its sign. So we're going to put a positive 2 in our box. We're going to put our coefficients in descending order and make sure every term is there. So we have 2x squared, we have a negative 5x, and we have our constant. Underneath our constant is our remainder box. So bring down the 2, multiply by that 2 in the box, combine them by the 2 in the box, and combine them. And so we found that when we divided this, our answer was, let's see, it started with 2x squared, so our answer starts with 1 less. So it's 2x minus 1 plus our remainder over what we divided by. That's the actual x minus 2. Now, when we're talking about a slant asymptote, it's also dealing with that end behavior. So as x gets really, really big or x gets really, really small, meaning it's just on the negative side of it. So just think about it. As this x gets bigger, the denominator is going to get bigger, right? And as the denominator gets bigger, then our fraction actually gets smaller. Because if you look at like 1/2, 1/4, 1/100th, okay? As that denominator gets bigger, that fraction's going to get smaller. So therefore, in the end, that's going to zero out. So when we're looking at a slant asymptote, we don't worry about the remainder. So our slant asymptote is just going to be y equals the 2x minus 1. So let's try that on pencil, problem number 7. Alright, so let's see. Does a slant asymptote exist? We have x squared and x. Top is bigger than the bottom by 1. So there is a slant asymptote. It is just x plus or minus an integer. So therefore I can use synthetic division. So it's x minus 3. So I'm going to put a positive 3 up here. We have our 1x squared, our 1x, and a negative 6. Bring down the first number. Multiply it by the 3 in the box. Combine it. Multiply it, combine it. Remember, remainder doesn't matter when we're doing slant asymptote. So our problem started with x squared, so our answer is going to start with x. So we get 1x plus 4, and for our slant asymptote, we're going to put y equals in front of it. And so there is our slant asymptote. All right. And if it didn't make us graph it, but just so we know that if we were going to graph it, it's a linear line, just use your slope and your y-intercept to help you be able to graph that. All right, and objective 8, solve applied problems involving rational functions. So solved problem 8 says a company is planning to manufacture wheelchairs. The cost C in dollars of producing X wheelchairs is C of X equals 500,000 plus 400X. 8a says to write the average cost function. Average cost. How do you find an average? You add it all up and you divide by how many there are, correct? Well, it's the same idea here. Okay, so we're going to add it all up, the cost, and we're going to divide it by the number of wheelchairs produced. So our cost is going to be equal to, I'm going to put it in terms of X. It's going to be equal to, how much is it going to cost us? Well, it's 500,000 plus 400 for each wheelchair divided by the number of wheelchairs we produce. Alright, 8B says to find and interpret the average cost of 1,000 and the average cost of 10,000. Alright, so we're going to take and we're going to plug in 1,000. So the average cost of 1,000 is going to be 500,000 plus 400 times 1,000 all over 1,000. Alright, so let's work that out. And if I did this correct, I got 900. So what does that mean? The average cost per wheelchair of producing 1,000 wheelchairs is $900. So if they're going to produce 1,000 wheelchairs, it's going to cost them, it's $900 per chair. Alright. So let's find the average cost of the 10,000. So 500,000 plus 400 times 10,000, all divided by 10,000. Alright, so we can put that in our calculator. But if I did this correctly, I got that it's 405. So the description is going to be the same. It's going to be the average cost per wheelchair I forgot producing up here. I knew that looked weird. Sorry, I was reading back through it. I'm like, that didn't even make sense. So the average cost per chair of producing 10,000 chairs is 405. Alright, and then 8C, I'm just going to work on the side over here because I don't want to have to lose what I've got here, but I can't pull it up with the rest of it. Alright, so 8C, it's down at the bottom on yours. It says, what is the horizontal asymptote for the graph of the average cost function? Describe this meaning for the company. Alright, so the horizontal asymptote, so just look at 8A. Where's the highest power of X? It's on both. Right here and it's right there. So we know that it's going to be y equals the a over b. So a is the 400, b is the 1. So we get that it's going to be 400. So what does that mean? Remember, the horizontal asymptote is that end behavior. It's a number that the graph is approaching, okay? So the cost per wheelchair is going to approach 400 as more and more chairs are produced. Alright, so the cost per chair will approach $400 as more chairs are produced. Alright, in pencil, problem number 8 is very similar. So it says a company is planning to manufacture mountain bikes. The cost C in dollars of producing X mountain bikes is C of X equals 100,000 plus 100X. Write the average cost function. So the average, remember, is the total divided by however many there are. So we're going to take our total cost. So the 100,000 plus 100x, and we're going to divide it by however many bikes we're going to manufacture. 8b wants us to find and interpret the average cost of 1,000 and the average cost of 4,000. So the average cost of 1,000 is going to be the 100,000 plus 100 times 1,000 all over 1,000. So we can put that in our calculator, and if I did that correct, I got 200. So the average cost per bike, the average cost of producing 1,000 bikes. So the average cost of producing 1,000 bikes is $200 per bike. Alright, let me erase some of this other stuff here so I have room. Alright, then it said the average cost of 4,000. So let's plug in 4,000. And so if I did that right, I got 125. So the average cost of producing 4,000 bikes is $125 per bike. And so I'm going to come up here to the side here, and I'm going to do 8C. 8C says, what is a horizontal asymptote for the graph of the average cost? Describe what this means for the company. Alright, so a horizontal asymptote. So we're going to be looking at 8A to help us. Okay, the highest power of x is both. It's top and bottom. So we know it's going to be the 100 over 1. So y equals 100 is our horizontal asymptote. Remember, that's the end behavior. That's what it's going towards. So as we manufacture, or as they produce more bikes, the cost is going to go towards $100. So the more bikes that have been produced, let's see, how do we word the other one? The cost per chair will approach $400 as more chairs are produced. So the cost per bike will approach $100 as more bikes are produced. Alright guys, and that is the end of 3.5.